All right, so today we look at the third way for finding a volume, and that is actually it's kind of the fourth way. We've talked about discs, we've talked about washers. Remember, with discs, the representative rectangle is perpendicular to the axis of revolution. If it's touching the axis of revolution, you have a disc. If it's not touching the axis of revolution but still perpendicular, you get a washer. So we're good to go on that. Then we talked about cross sections, which really doesn't have to do anything with revolutions. It's just stacking shapes on top of another base. Today we get another method, which is called shells. What happens if you can't get a representative rectangle perpendicular to the axis of revolution? It's actually parallel to the axis of revolution. And that's where we use the shell method. So you should be able to define the solid of revolution using the shell method and compare. This is going to be the hard part. Deciding which method to use based on any given problem. It's not necessarily going to say using shells, find blah, blah, blah. Using a disk, find blah. You're going to have to be able to look at the problem, draw a picture, and analyze, oh, I should use discs, I should use washers, or I should use shells. And then, of course, you should be able to perform CPR on someone who needs it. Not just a random stranger, someone who needs it. Can you do CPR?
No.
No?
I didn't get certified, so
Call 911, get the AED,
Question?
and come back.
Can you?
I can. I am certified.
Teachers have to be certified.
Teachers have to be.
I think so.
I think so, because we have like a little CPR party every year and everybody gets trained.
Yeah,
Oh, that's
that
fun.
means you're
Yeah, it is
required
fun. All of us in the field house with those plastic things.
Yeah.
It is a blast. Okay, so we talked about that already, and let's go back to Sketchpad. Stop the background chatter, please. Okay, so shells were back here. Nope, they were not. They are back here. All right, so here's my representative rectangle. Here's my axis of revolution. And again, that representative rectangle is parallel to the axis of revolution. So when you revolve that, you get what's called a shell, which is basically a cylinder with a hole punched through it. How do you find the volume of that thing? You don't. Good answer, Dave. That'll take you far in life.
Total minus the inside subtracted.
Say again?
Total of it all minus the inside punched out subtracted from
Perfect.
the total.
Yep. It's the whole cylinder minus that hole that's punched through the center. So you're going to calculate the volume of something that's not there. Okay. And then staying with the same format that we've talked about, if we find all the shells together and add them up using the accumulator, then we'll be able to find the volume of that thing. So if we see what that looks like, commonly called nested shells. So there's the first shell. And then when we build all of them, you can clearly see, well, that's a train wreck. You can clearly see how you get that. Let's get rid of that and change this number. Right, but I need my keyboard. Let's make it 20. Okay, close that. And see all the shells. You end up with that freaky looking thing. We did, that's discs and washers. I think I got one other one here. Spin region shells, here it is. Okay, so we take that puppy and revolve it. And we end up generating that shape, and that's made by building a bunch of shells from zero outward. Okay. All right, so how do we do that? Well, we need to talk about a couple things as far as the shells go. Don't write this down, but I do want you to see where these formulas come from. Again, I'm not a big fan of memorizing. So I took a shell and I labeled it with a couple different things. R1 represents the biggest distance. It's from the center or the axis of revolution out to the farthest point on the shell. R2 is the inside radius. Delta R is the thickness. That's the height. And then this little case, lowercase r with no subscript, represents the distance to the center of the shell. if we want to get an answer as accurate as possible, how thick do we want the shell to be? We want an infinite?
Almost 0.
Almost 0, correct. Okay, so this is, let me explain this a little bit. The first line is what Tyler said. We're going to take the outside distance, or outside volume, which is the volume of the whole shell, and subtract the hole in the middle. So the first chunk is the volume of the whole shell. The second chunk is the volume of the hole that's punched through it.
Mr. Reed,
Yes, sir.
in that picture, what's the difference between R and R1?
R1 goes, hold on, let me get a pen here. R1 goes all the way out to the edge.
Yeah.
R2 goes to the inside edge, and R goes to smack dab in the middle.
Oh, okay.
Okay, we'll get to that in a second.
Got it.
Wait, Mr. Reedy.
Yeah.
What's the 1 and 2?
They're just subscripts.
So, like.
You're talking about this 1 and this 2, right?
Yeah.
Yeah, they're just subscripts to identify the different radii.
Did you say not to
So,
write this down?
it's saying like radius 1 or radius 2?
Correct. Radius 1 and radius 2, yes. They're different distances.
You also know.
They- Yes. Second line, I did some algebra. I factored out the common factor of pi h, and I'm left with r squared, r1 squared minus r2 squared. I factored that. That's a difference of perfect squares. So you can factor that. Square root of the first minus square root of the second, square root of the first plus square root of the second, and got to the third line. And then I did some manipulations here. Well, I cheated. I wanted a 2 there, so in order to put a 2, I had to put a half there. Or I needed a half there, and I put in a 2. Regardless, I made those two numbers magically appear. You'll see on the next slide why I need those two numbers. Okay. First things first, R1 plus R2 divided by 2 is the average radius of that shell, also known as the thickness. And that's why I needed the 1, I did need the 1/2 here. Because I want to turn this expression, the 1/2 times the quantity R1 plus R2, into the average radius. And what do we want that average radius to be? I'm sorry?
As close to 0 as possible.
Good, and how do we represent that?
Yeah.
dr, dx, dq, whatever we're dealing with at dq. Dairy Queen, get it? And then R1 minus R2 is the thickness.
Did you say not to draw a picture?
It's entirely up to you. This is America.
I thought you said.
Yeah, didn't you say not to write any of this down?
I did, yeah. You don't have to write it down. Some of you are bucking the system and want to write it down. That's okay. I'm not going to stop you from writing anything down. I'm not going to make you put your pencils down. Do you have too much caffeine today or something?
Oh, I haven't had it.
No, not you. I'm talking to Ian. You're fine.
Ian's going crazy right now.
I can see that.
Staying notes.
Bad case of the jitters.
Jingle tail.
Okay, so we get this. Oh, I was mistaken. I'm sorry. The average radius, let's go back.
Oh, are you kidding?
Oh, shut up. The average radius is not the thickness. The average radius is the distance from the axis of revolution out to the shell, because we can have shells of different sizes.
Wait, can you say
Okay,
that?
so delta R is the thickness. We want that to go to 0. And the average radius is the distance from the axis of revolution out to the shell. So if I've got a big wide shell, it's going to have a bigger average radius than than something that's really tiny. Okay, now that gets us to this. The average radius is that distance from the axis of revolution out to the shell itself. Delta R is the thickness of the shell, which leads us to the last statement. If I combine the delta R plus the H, those would give me, those two combined together, in other words, the thickness times the height would give me the area of our representative rectangle that generated that shell, and then the average radius is the distance away from the axis of revolution. And all of this is the derivation to get to that formula. That's a general formula for shells. Now this is going to cause some problems for people for a couple reasons. Number one, notice there's a 2 pi now, not a pi. For discs and washers it's pi, for shells it's 2 pi. The other problem is going to be understanding what all the notation is. So remember, x is the distance away from the axis. It's not always going to be x. It'll be x initially when we're revolving around a y-axis or an x-axis. And then that f of x dx represents the area of the rectangle. F of x is the y value, dx is the thickness. This you probably want to write down because it's in a colored box. Universal indicator for write this down.
I have a headache now.
Great. Halfway through the lesson, you've developed a headache. That's a good sign for the future. It'll probably get better. Don't worry about it.
I hope
I
so.
have no idea what's going on.
So here's what happened. I took that weird looking, I took a function over there, f of x, and I drew a representative rectangle there, and then I spun it and it generated a shell. Nothing fancy. And then if I integrate it, I can add up all those shells and it'll give me the volume of the figure. So here's our first example. Find the volume of a solid generated by rotating the area between y equals 6x minus x squared and y equals 0 around the y-axis. So first of all, in your notes, draw a picture of what the region looks like. Do that on your own. You might want to use your calculator. I don't know. It's up to you. And then we'll start solving the problem.
Okay. I don't like this anymore.
I've never been.
I like pictures.
I'll give you a picture in a second, but you got to do a little more.
Derivatives. I like the division. That's not even a calculator. That's not like that.
I like when we added numbers on a number line when all I had to do is count.
And there weren't even negatives either.
Right. There's no such thing as negatives. 0 was a little shaky too.
Yeah. No fractions either.
No, fractions bad.
Yeah. Oh.
Of course, now kids are doing fractions coming out of the womb, right?
Yeah.
Let's push it. Gotta do fractions. I think I did fractions in like 3rd grade the first time. Now they do them in preschool. What do you got there, Slick? Oh, all right, good. Getting there?
Wait,
Should we do one of these? What do you think? I'll have to look at that. And when I don't do anything about
Got some happening, probably.
that. Nice. Don't know what to do about it though.
Good. All right, so most people have an idea what it looks like, yes?
Yes.
And notice that we're doing the region bounded by the function and y equals 0. What's y equals 0? The x-axis. So we're taking that upside down parabola that you found and chopping it off at the x-axis. So we get this picture, okay, the stuff in blue. And so I took the stuff in blue, which is the region we're going to deal with, and I created a representative rectangle. That's the fancy red rectangle.
How do you get that?
How do I get that?
Yeah.
I just made it. I picked somewhere in there and I drew a rectangle. Could be anywhere. You can put yours wherever you'd like, as long as it's in the region. How far away, oh, and also we're going to revolve around the y-axis. So we're at this guy. How far away is that rectangle from the axis of revolution? X. Why x? Because I chose it to be x. That's our variable here. We're going to end up taking rectangles that are a whole bunch of different distances. That should not be a numerical value. That should be a variable.
That just goes to the rectangle, like the inner part or the outer part. Or...
Yes. Because remember, our rectangles are going to be really skinny, so instead of thinking about, this is where it's a little deceiving. I actually drew a physical rectangle. Your rectangle in the real world is going to be a segment, right? Okay. How thick is that? Well, we've said this a gabillion times. We want it to shrink down to 0, which we'll represent with dx. And how tall is that rectangle? Right. F of x, but in this case, it's 6x minus x squared. So for a shell, we need two things. We need the distance that rectangle is away from the x-axis, which is x, and we need the area of the rectangle. What's the area of that rectangle? Say again, Dave?
6x minus x squared dx.
Good. There's the height of the rectangle. We did that already. There's the area of the rectangle. Dane just told us that. And then we integrate it from what to what? 0 to 6. Because we're sliding rectangles this way from 0 to 6. Casey, what's your question?
So the area, was that from do it? You don't have to use the top minus bottom.
You do.
Is that how you?
Yeah, but the bottom is 0. So 6x minus x squared is 0. That'll come up later where it won't be the same.
Okay.
Remember that, what is this thing? A shell has a 2 pi, not a pi in front of it. And we get that.
How did you know?
Because that's where I'm taking rectangles from. I'm starting the first smallest rectangle at 0. I'm generating rectangles all the way out till 6, and I stop at 6.
You set them over to each other? You set them?
Yeah, set this. Yeah. Are we okay with where the 6 came from? I mean, I had it in the picture, but would you be able to find that 6?
Yes.
Good. Okay, set the functions equal and solve. Yeah.
Is the distance always going to be x?
You know I don't like to use always. Most of the time, if you revolve around the y-axis or the x-axis, the distance will always be x or y. But of course, that would be too easy. We're going to move it around some other lines in a second. Yeah.
How do you know when to use either the washer method or the shell?
Awesome question. Hear that?
I don't like your question.
Hot? Okay.
It brings forth difficulty.
Grant didn't like your question. So we're just going to skip it and move on. Is that okay? In this particular problem, I used a vertical rectangle. Vertical and horizontal do not determine what method you're going to use. My rectangle is vertical. What's my axis of revolution?
Y-axis.
Y-axis. Is my rectangle perpendicular to or parallel to the axis of revolution? Parallel. So if it's perpendicular, you're going to use a disc or a washer. And then you got subsets of that, whether it's touching or not touching. If it's parallel to the axis of revolution, you're going to use a shell. Okay? That's a great question. You good with that?
So this isn't like 7-1 at all?
Yeah, we're spinning around the y-axis.
Wouldn't you just be able to write horizontal using the washer method?
Wow, that's two awesome questions. So she just asked, well, couldn't I do it horizontally and use the washer method? Because it would be washer because it doesn't touch. There's a small problem with that. If I did it with in terms of horizontal I can't even speak today. Horizontal rectangles, I would need to solve this for x. You know how to solve that for x? No, I don't want to either. So you'll see that, like, I personally like the disc and washer method better because that's how my brain works, but there are going to be some problems like this where you're bullied into using the shell method. And I'm going to write problems that are going to bully you into using the shell method because I want to make sure you can do the shell method.
You're a bully?
Okay. Well, you just realized I'm a bully? What do you want? Disc method if it's touching the axis of revolution, washer method if it is not. Okay, we good?
Yeah.
I would assume you would be able to do this, either fn int, multiply it out. I mean, it's not too bad. I would distribute the x, 6x squared minus x cubed, integrate, plug in 6, plug in 0, get an answer. Most common mistake with these problems, two things. Number one, you use pi instead of 2 pi. And number two, you simply forget to multiply your answer by 2 pi. Don't do that. Remember, there's 2 pi floating out in front. So I did all the work. I multiplied it out. I took that. I got that. Next example.
Wait,
Want me to go back? You care about the answer? Okay. All right. Easy. All right. Okay. Here we go. There you go. I didn't do the answer. I got that. I stopped. I gave up. If you want to make sure you got it right, fn int.
Yeah, I don't care that much.
And then you have to
Wow. All right. This is going to be fun. You know it wasn't going to be that simple.
It never
She
is.
wasn't ready for you.
That was
to
the
rotate
joke.
it.
Is this a shell and wash?
Who was it?
Oh,
I got it.
rotate
I got
around the
stuff.
x, so it's like 5 minus whatever.
I understand.
Yeah,
Just like
that's
for a
all it
second.
is.
Okay, so find the volume generated by rotating the area bounded by x squared plus 2. That's just a parabola shifted up to the line y equals x plus 4. That's obviously the line there. And around x equals 5. So now we're not moving around the x or y axis. Okay. So I did some things up here that you would have to do on your own. So for instance, I found the points of intersection. Set the two functions equal, solve for x, and then plug it back in to solve for y. Then I took the, what did I do? Wait a second. I don't know why this says x squared, not x squared plus 2.
It's not the right
It's not, yes, not the right. All right, we'll go with it anyways. It's okay. We're all right. We're all right. We're okay. We're okay. Question number 1. Disc washer or shell?
Shell.
Because we're in the section on shells, it's probably a shell problem, but how do you know that?
Reasoning.
Carolyn?
It's parallel.
Parallel to?
The axis of sorry.
I'm sorry?
The revolution axis.
The axis of revolution.
Yeah.
Right on. Here's our rectangle. Here's the axis of revolution. It's parallel. Therefore, we're going to use a shell method. We need two things for the shell method. The distance the rectangle is away from the axis and the area of the rectangle. Let's do the rectangle first because that's easier. dx, it's really skinny. That's no problem. How tall is that?
Top minus bottom.
Top minus bottom still comes into play here. Top is the line, x plus 4. The bottom is the parabola, x squared plus 2.
Minus x squared plus.
Wait.
Except you don't have.
I don't have an x squared plus 2 over there. Problem solved. Shh. There's that better? There's the height of the rectangle. There's the area of the rectangle. We just multiply it by dx. That's the easy part. Now the hard part in this problem, how far is that rectangle away from the axis of revolution?
5 minus x.
Why?
Because the axis of revolution and then the distance from it is x. So you have to do x minus 5.
Everybody follow that?
No.
Okay, a couple ways to think of it. If we go back to the other problem that we did, we forced the rectangle to be x units away from the y-axis. So let's call that x. This distance is 5. How long is that distance? That's one way to think of it. However, the way I think of it is the rectangle is at x. This is 5. Staying with the idea of right minus left gives me this distance as 5 minus x. Okay? If the axis of revolution is on the other side, then it would be x minus whatever. Still staying with top minus bottom for the height of the rectangle and right minus left to find that distance.
Mr. Reedy, I have like a side question. For extra credit on like the tests or quizzes, can we like draw like the 3D version?
Ooh. You think you got the chops to handle that?
Like it'd be tough, but like you could probably do it. Like that would just be like a cone.
I'll think about it. My only concern is when you put the 2 words extra credit on a test or quiz, people tend to freak out and go for that and don't do the basics. But if it's a shorter quiz, yeah. We can take a look at that. Okay, we just did that. The distance from the rectangle is the distance of rectangles from the axis of revolution is 5 minus x. So what's the complete integral? Where are we taking rectangles from? From what to what?
-1 to 2.
-1 to 2 is correct. Got a 2 pi out in front of it. The distance away from the axis of revolution is 5 minus x, and the area of that rectangle is right there, which leads us to, oh, there's the points of intersection, did that. Okay, so we got that monster. That's fun.
I found it.
Wait.
Yes?
So when Kelly said there's always x and you said you don't say always this, but not always because it's
So I can now that we've seen this example, let's go back. The rectangle will always be x units away from the y-axis,
okay, but we're not doing
but it won't always be x units away from the axis of revolution. Let's suppose you don't have a calculator. How do you solve that integral? Did you say cry? Okay, cry. Okay.
Sob.
You're just like holding your quiz up as the tears drop onto this. Okay, now the realistic answer.
Multiply it out.
Multiply everything out, you have to. Simplify this stuff inside, you'd get negative x squared plus x plus 2. Multiply that monster by 5 minus x. And then take the integral of each of those parts. So I did that, and then I got to that. Ooh, that's fun. Okay.
Where did you get the 5 minus x again?
That's the distance from the rectangle to the axis of revolution. And since the axis of revolution isn't the y-axis, I did right, which is 5, minus left, which is x. Okay?
What?
Once you multiply it out, that's a fairly easy integral. And so we move on to our next example.
Wait, can you
What?
go real fast?
I got stuff to do. I'm a mover and a shaker.
You had another example?
What do you think? Some Gouda?
What?
A sharp cheddar?
For your one.
Yeah, what kind of cheese you want to go there one? I only have like 4 jokes. I just use them over and over again.
Save your hay, you meant your
That's another one.
I haven't heard that
What are we talking about?
I was born ready. They spelled it wrong. That's another one.
one. That was so bad.
I was born
What are you talking about? That's comic genius.
What is the one you said to the girl I got in the classroom today?
I don't know. I think she asked me a question. I said, I don't know.
No, she asked if she did the work correctly or something like that.
Oh,
Maybe.
How long is the quiz?
She said you.
oh there's another one. How long's the quiz? Yeah,
and you
11
said-
inches. It's 8.5 wide. Yeah. Is that 4 now?
I think it's 3. Yeah, it's only 3.
No, it's
got the right.
it's what kind of cheese do you want to go with that wine? Save your hay, my marinade
Oh, I
someday.
didn't this thing.
I was born ready. They spelled it wrong. How long's the quiz? 11 inches is 8.5 wide.
There you go.
Oh, I was born at night, but not last night.
Oh yeah, I don't use that one that
Oh,
often.
you said it before.
It is a good one.
Well, we said the quiz easy.
Oh, I got it.
I got it.
Oh
Oh yeah,
I
that's
took
it. We're up to 6.
I got A plus.
Yeah. How hard is the quiz? I don't know. I got an A plus.
Yeah.
No. Give myself a sticker.
Do we have to?
No one tell us that we can't run partners.
Yeah, we haven't gotten stickers in a
It's
while.
America.
Yeah, where's my sticker on my quiz from yesterday?
Yeah.
It's the
When
first
we
one
have
I
a
won,
down
sticker.
day, I will do some.
Yeah.
I will. Okay, shh. When we have it, I'll do some sticker shopping this weekend. And when we have some downtime, I will go back to the beginning of the semester and reward
Oh my.
stickers. I admit that I have been lacking on that. All right. So Maddie, you know, you were kind of throwing down the gauntlet. You think you can? What? You think you can fire off that donut-looking thing on a test or quiz? I can see you like at the end of the quiz, you reach in your bag and pull out like the 100th set of colored pencils and stuff. Shaded, different, yeah, okay.
Well,
Or just, no, you brought in the big thing, 100 crayons.
Yeah.
Right? Yeah. That'll look great in crayons. Yes, Pat.
No,
So
it's-
we've been rotating everything about around like a line. Are we ever gonna have to rotate it around like an equation?
No. I know. I'm sorry. This is rough a little bit. But no. I don't even know if that's, well, it is possible. Because you could take,
I don't think it is.
yeah, but we don't want to go there. Everything's around the line.
Good.
Yeah. Okay, so in this case, this one's a little different. What's different about this problem from the other 2 examples we've done? It's in terms of y. How do you know that?
Because it's sideways and it says y.
It says
Good. Okay. So first indication that I've solved the function for x already. Not solvable for y. So therefore you're, again, this is in a situation where you're being bullied into using y's. Also the other indication is that the axis, or the rectangle is horizontal. Could you do this problem with vertical rectangles? Well, if you knew what this function was in terms of x, you could, but then you get into this weird thing with, well, the top of that is the positive part, the bottom, and it's easier, believe it or not, to do this with a horizontal rectangle. Okay? What's the area of that rectangle?
2y cubed minus y to the fourth.
2y cubed minus y to the 4th
dy.
dy. Very good. How far is that rectangle away from the axis of revolution?
Y.
Y. We're taking rectangles from where to where?
0 to 2.
0 to 2. Done. not so bad. So,
We didn't move it up.
a needle pulling thread?
Oh, joke number 7.
Just have a tally.
I'm
Yeah.
going
Because that's
sticker
it.
shopping this weekend and I'm getting some new jokes.
A joke.
Yeah, a joke book. I'm just gonna, hold on a second, let me turn to page 17. Joke number 325.
Wait,
What? Write faster!
why are you such
There's
a
nothing to
person
write!
with the last
What are you doing, drawing the picture?
He likes showing
Save that for Maddie.
line? You always do that. The last slide you get so excited I'm going to.
No, I just want to get done.
You
I got
just
stuff
so
to do.
pale.
The belt's gonna take in 3 minutes.
Wait, no.
Alright,
I'm not ready to.
go. We're ready. We're ready.
No, we're not.
Yeah, we
Oh,
are.
we're-
I'm definitely not ready.
What are you not done writing?
Right? Right?
What's that?
I said we're not ready.
How long does it
No,
take to
don't.
write this?
That is before we even got into that.
No, they're just.
Even that?
Oh, for God's sake.
Supposed to turtles in a half shell?
You just want to
You can copy mine.
From 3 Tuesday, I was like, I thought you were like, wow, you're gonna go pay them that?
3, 2, 1.
2, 3. No.
Thank you, Mr.
Here,
This makes no sense. Oh, shell.